Hi, in this video we will be exploring the concept of ultrasound. Now, ultrasound is essentially waves with a frequency above 20 kilohertz, and the human hearing range is from 20 to 20 kilohertz. So that basically means that humans cannot hear ultrasound. Right. Another thing you need to know is that ultrasound is a longitudinal wave and travels at 1,500 meters per second in water. Now, what are the uses of ultrasound? The main use of ultrasound is in echolocation. Lots of animals like dolphins and bats use ultrasound specifically for echolocation. Right? Now, let's look at an example for this, right? Let's say you have a bat. Okay, whatever. I don't know how to draw it. But anyways, this is a bat, and it's in a cave and it can't see right now. And let's say you have a wall over here. Now, how does the bat not collide into that wall? Let's say it's going forwards, right? How does it know that, oh, there's a wall here, I need to move away, right? So what it does is it sends out this pulse of ultrasound, and when the ultrasound touches the wall, right, it is reflected. So it's reflected back. And what the bat essentially does is it uses the time taken to hear the reflection of the ultrasound pulse to calculate the distance, right? And that's why it's able to see. That's why even though it's not able to see, it's able to navigate, because bats essentially can calculate or approximate the distance using the time taken to hear the reflection. Now, another use of ultrasound, similar to bats, right, is using sonar equipment for echolocation in boats. So basically, let's say you have a boat. This is water, and then you have a boat here. And at the bottom of the boat, what you have is you have sonar equipment. And what this equipment does is it emits ultrasound. Let's say you have some fishermen and they want to detect some fish. So let's say you have fish over here, here, here. Now what it does is it sends out this ultrasound. And then when the ultrasound touches these fish, it's essentially reflected back. And similarly, right, the distance is calculated. And this time the exact distance can be calculated by the sonar equipment. So as you know, the equation is distance is equal to, right, distance is equal to speed times time. Right, and you know the speed, if I remember correctly, it's 1,500 meters per second in water. So distance, and then so what you just multiply that 1,500 times the time taken for the pulse to come back, and then what you do is you divide the distance you get by 2 to get the actual distance, because the time you're getting is the time it takes to go here and come back as well. So it's basically doubling the distance, right? So you need to half it to get the actual distance. Otherwise, it's like saying, oh, it went all the way here. And that's not actually the case, right? So now there are some other uses for ultrasound, which include destroying kidney stones and fetal scans as well. So let's take a deeper look at fetal scans. So usually you have a probe, and what this probe, you put it on the mother's stomach, and then what happens is the probe, you put gel, first of all, you put gel on the stomach to prevent reflection, so the ultrasound actually goes through from the probe, and then it passes through the gel and it enters the stomach. And what happens is the fetus is inside, and essentially at different layers, once the ultrasound is emitted at different layers, there are multiple reflections, right? Partial reflection at each layer. Not all the ultrasound goes through, not all of the ultrasound is reflected. There are partial there's partial reflection at each time, and that series of partial reflections essentially allows a sonogram to be built. Sonogram is basically the image of the fetus, and that those partial reflections allows an image of the fetus to be constructed, right? So you put gel on the mother's stomach, so the ultrasound is not reflected from the stomach, it actually goes through, and 99% of the ultrasound goes through. And once that ultrasound goes through, it reflects at different boundaries, right, in the fetus, and that allows us and then once there's reflection, the series of reflections builds an image, and that image is essentially the image of the fetus, which produces the sonogram. Okay, now basically the reason why ultrasound is used for detection and imagery is because it has a frequency above 20 kilohertz, right? It has a frequency above 20 kilohertz. And so, as you know, frequency corresponds to energy. So the energy is very high, which is why the wave is able to reach the detector, right? Lower energy means lower amplitude. So if you had a normal sound wave, if it's like emitted, reflected, by the time it reaches the detector, a lot of it would have been absorbed, and so the energy would be very low, the amplitude would be very low, it would be very faint, and so you wouldn't be able to detect it properly, which would create inaccuracy. But with ultrasound, energy is very high, it's not faint, you can detect it properly, which decreases inaccuracy, right? Sometimes in like certain cases, sound waves wouldn't even be present because all of the distance is too great, all of it's been absorbed, right? So that's why you use ultrasound.